Hello, this is Gallagher Fluid Seals. Today we are continuing our segment on Kalrez and its chemical resistance capabilities. Today's agenda will take a deeper dive into the chemical and thermal properties of Kalrez. In the next few minutes, we'll take a close look at how Kalrez parts fight leakage, prevent expensive maintenance and downtime, and we'll look at 3 general-purpose compounds. With Kalrez, you can help ensure your plant against leaks and costly seal failures. In virtually any sealing application, from mechanical seals to quick connect disconnects, Kalrez parts stand up to heat and chemicals that degrade other rubbers and sealing materials. Kalrez combines the superior characteristics and properties of DuPont's high-performance Teflon and Viton. Experience has proven Teflon's high resistance to chemical exposure. As a plastic, however, it is damaged by solid contaminants as a sealing material, and Teflon will cold flow. Both of these conditions can cause permanent distortions and leakage in a seal. Unlike Teflon, Kalrez is an elastomer, or rubber. It stretches and recovers from compression, much like conventional rubbers, but it maintains the chemical resistance of Teflon. It resists attack by chemicals and solvents widely used in chemical plants and refineries, as we discussed in the previous chemical resistance video. The development of Viton raised the high temperature limit for rubber parts to 400 degrees Fahrenheit. Kalrez has extended those limits further, performing up to 600 degrees Fahrenheit. Performance qualities like these have gained Kalrez worldwide acceptance backed by decades of outstanding performance in the field. Success has increased the demand for Kalrez, and its consistent growth has been evident over the past decades. Where long-term seal life and aggressive chemicals is a necessity, conventional rubbers will not solve the problem. Imagine one rubber that will handle acids, bases, ketones, as well as solvents, in ether or ester service, or a process requiring amines or aldehydes. And this is only a partial list. Kalrez is A-rated, virtually unaffected in 1,500 additional chemicals and fluids listed in the Chemical Compatibility Guide. Some plants may have dedicated process lines for a single fluid. More commonly, however, lines are used to process a number of different chemicals over a relatively short period. For example, a production line may be used for solvents, then steam purged during shutdown, and used again for an entirely different chemical. Sealing materials used in these process pumps must be capable of handling a wide variety of highly corrosive chemicals. In most plants, rubber sealing materials must also withstand heat transfer, fluids, or high-temperature oils. Even more often, the sealing material will also be exposed to hot water or steam containing additives from the treatment of boiler feed water, solids carried over from steam generators, and in some cases, amines, hydrocarbons, or caustic materials. Even small quantities of these contaminants will degrade other rubbers at moderate temperatures. Even in steam, without contaminants, where temperatures exceed 350 degrees Fahrenheit, other rubbers are marginal and service is limited. Kalrez has proven effective in many of these steam applications. Kalrez will withstand nearly all chemicals and solvents, though a few may cause swelling. Depending upon operating temperatures and design considerations, Kalrez should be carefully evaluated in applications including certain freons, chlorine, fluorine, ethylene diamine, and hexamethylene diamine. Under no circumstances should Kalrez be used with liquid sodium or liquid potassium. Since it's with Teflon, the fluorine content may react, creating the potential for explosion. Because Viton resists more chemicals than any other conventional rubber, comparisons of Kalrez here are limited only to Viton. Test results show chemical immersions at room temperature for 1 week will result in some degree of swelling for Viton, while Kalrez is almost unaffected. A 25% volume swell in rubber is generally beyond the tolerable limits for a functional seal. These values resulted from exposure at room temperature. As temperatures rise, volume swell can increase significantly. For every 20 degrees Fahrenheit increase, the reaction rate of a chemical or solvent will double. A 100 degree Fahrenheit rise will increase the rate of chemical attack over 30 times, which can reduce service life. In more hostile chemical environments, it is apparent that Viton would swell rapidly, extrude, and fail, and more commonly used rubbers would fail even more quickly. As chemical plants and refineries are more energy and cost conscious, operating temperatures often climb beyond the practical service limit of conventional rubbers, a situation well suited for the high temperature advantage of Kalrez. Exceeding the high temperature limits of any rubber will lead to loss of physical properties. This includes softening, loss of compressibility, and eventual hardening and embrittlement of the material. Sealing force is lost, resulting in seal failure and increased maintenance and repair costs. The high temperature capabilities of conventional rubbers such as butyl, EPR, and nitrile have upper limits of 300 degrees Fahrenheit or less. Fluorosilicone, silicone, and Viton offer an extended range of 400 degrees Fahrenheit or less. Viton has the best combination of chemical and high temperature resistance of any conventional rubber. Again, let's compare Kalrez to Viton and retention of sealing force under high temperatures. Using the standard hot air testing method for measuring the comparative performance of all rubbers, Kalrez and Viton in 450 degree air initially exhibited sealing force retention. In approximately 1 month, however, Viton has completely embrittled, lost all of its sealing force, and failed. Kalrez, after nearly 3 years, still maintained sealing force. With exposure at 400 degrees Fahrenheit, the upper limit for Viton, it would have lasted for only 6 months. At 500 degrees Fahrenheit, Viton would have failed in less than 10 days. Kalrez, at any of these temperatures, continued to maintain a seal and prevent leakage. Process temperatures at your plant may not reach the limits used in these tests. In many plants, it is highly aggressive chemicals that limit the service life of conventional rubbers, even at temperatures below their thermal limits. To prove that point, nearly 100 successful applications where Kalrez replaced conventional rubbers were analyzed. A majority of uses, nearly 60 applications, were under 300 degrees Fahrenheit, well within thermal capabilities of butyl, EPR, and nitrile rubbers. An additional 20 applications used Kalrez between 300 and 400 degrees Fahrenheit. Out of 100 applications then, 80 were successfully using Kalrez under 400 degrees Fahrenheit, the upper limit for Viton. When choosing a rubber sealing material, the chemical and solvent resistance required for your application is even more important than the high temperature limits of rubber. The superior heat and chemical resistance of Kalrez, proven in field applications, can lead to the major benefit of cost savings. In your plant, overall objectives for each employee include safety, improving efficiency, cutting costs, and saving money. Kalrez gives you many opportunities to do just that. The outstanding performance of Kalrez is the result of its unique balance of properties. Properties that add up to proven dependable service, long-term performance, and reduced maintenance and downtime. Using Kalrez parts gives your plant an advantage. Long-term dependable service plus reduced maintenance costs equal money saved. A market research study performed decades ago analyzed many types of chemical process equipment to determine the average cost of a failure. These results may be similar to expectations for your own plant, although individual analysis of maintenance costs is recommended. The range of pull or turnaround saved by using Kalrez averaged from 4 to 6 over a broad range of applications in many different plants. Although this figure may not be typical of your experience, Kalrez can still prevent unexpected breakdowns and improve turnaround frequency. For a typical ANSI process pump application, the cost per pull averaged $270, almost half for labor. The rest for seal parts requiring replacement due to failure. When substituted for conventional rubber, Kalrez parts saved an average of 5 pulls, resulting in reduced costs of $1,350. In this study, the price of one 2 3/4 inch by 1/8 inch Kalrez O-ring was $125. The net savings, $1,225. In other words, for every dollar spent, $10 was saved. Conventional rubber sealing materials used on mechanical seals in high temperature and pump applications often require external cooling, a costly process involving insulating material, labor, and the expense of maintaining a hot water or steam flush for these jacketed pumps. Substituting Kalrez will eliminate cooling requirements completely for substantial energy and cost savings. Another study performed decades ago studied API process pumps found in refineries and some chemical plants. The average cost of labor and parts on these pumps exceeded $1,300 per pull. By substituting Kalrez, an average of 5 pulls were saved. 3 4-inch by 1/8 inch Kalrez O-rings were used at a total cost of $500 back then, resulting in a net savings of well over $6,000. For every dollar spent on Kalrez, $12 was saved. In this study, process valves and instrumentation associated with these pumps also realized similar cost savings by using Kalrez. These results prove that in virtually any plant operation, from pumps to valves, Kalrez can offer the final solution to your sealing needs. To this point, we've discussed only the simple substitution of Kalrez for commercially available rubbers, most of which are made into O-rings and various other shapes by a number of different manufacturers. Each of these manufacturers has a wide variety of compounds available for each rubber. As a result, the selection of the optimum compound can be extremely difficult. To make your selection of Kalrez simpler, 3 compounds cover virtually any service: compounds 4079, Spectrum 6375, and Spectrum 7375. DuPont Kalrez 4079 perfluoroelastomer parts are a low compression set product for general purpose use in O-rings, diaphragms, seals, and other parts used in the chemical process and aircraft industries. It is a carbon black filled product with excellent chemical resistance, good mechanical properties, and outstanding hot air aging properties. It exhibits low swell in organic acids, inorganic acids, and aldehydes, and has good response to temperature cycling effects. A maximum service temperature of 600 degrees Fahrenheit is suggested, with short excursions to higher temperatures possible. Kalrez 4079 is not recommended for use in hot water or steam applications, or in contact with certain hot aliphatic amines, ethylene oxide, or propylene oxide. To meet the needs of chemical processors, DuPont Kalrez 6375 parts offer broader chemical resistance while maintaining the temperature stability you've come to expect from Kalrez. 6375 is designed to give outstanding performance in the widest possible range of chemicals and temperatures. Mixed streams, once a problem for many chemical processors, can be handled by 6375. Furthermore, the curing system also allows for maximum service temperature of 525 degrees Fahrenheit, which translates to increased chemical resistance over all temperature ranges, especially if high temperature process excursions occur. This combination of chemical and thermal resistance provides advantages for chemical processors. DuPont Kalrez Spectrum 7375 perfluoroelastomer parts are an innovative FFKM product based on a patented cross-linking system for chemical process industry applications where broad chemical and water or steam resistance are needed at elevated temperatures. 7375 parts exhibit excellent compression set resistance, outstanding physical property retention, and good mechanical strength properties. A maximum application temperature of 572 degrees Fahrenheit is suggested. Kalrez parts are manufactured only by DuPont and are backed by DuPont's reputation for quality and progress in rubber technology. Kalrez is available in standard size O-rings, rod stock, and tubing for applications as diverse as mechanical seals, centrifugal pumps, mixers, and control switches. Kalrez is used in both safety relief and unloading valves in equipment for transporting chemicals or finished products. DuPont can make custom design shapes and sizes, ranging from gaskets to diaphragms, T-seals to U-cups, or nearly any special part required in your place. These standard and custom parts are available through a network of authorized distributors, like Gallagher Fluid Seals. Gallagher is a Tier 1 Kalrez distributor and is technically trained to work with you on Kalrez applications, recommendations, the correct compound, and providing reject O-rings for use in immersion tests when comparing Kalrez to other rubbers. Immersion testing results in proof positive that Kalrez is the material of choice in nearly all applications. After determining your application needs, Kalrez authorized distributors like Gallagher will stock your part requirements. In review, Kalrez combines 2 chemistries, Teflon and Viton, in a unique rubber sealing material. It has the superior chemical resistance of Teflon and high temperature capabilities well above that of any other rubber, up to 600 degrees Fahrenheit. Gallagher Fluid Seals can help you determine how Kalrez can be used in your plant. Kalrez provides proven dependable service, can save an average of 4 to 6 pulls, and results in reduced maintenance and downtime. The bottom line, Kalrez parts can save you money. Considering the facts you've seen here, can you afford not to have Kalrez in your plant? Before we sign off, and as a reminder, highly toxic products can be generated when FFKM parts are exposed to fire or temperatures in excess of 750 degrees Fahrenheit, so respiratory equipment should be used if ventilation is inadequate. Also, FFKM should not be exposed to alkali metals or interhalogen compounds as they are incompatible with both. Join us next time for the final video in our Kalrez video series, where we will discuss thermal stability and selected critical performance properties. Thank you.